Good day, everyone. Hello, good day, everyone. How are we all doing today? Um, we want to look at the concept of partial differentiation today. And the thing is that a video has actually been done on partial differentiation, but students who are watching it, some of our students who are watching it, they don't get to understand partial differentiation as fast as I want them to. So I'm going to I want to record it again, do a new one, and of course, teach it in a way that I think is simpler for everyone to understand. Now, when you're doing differentiation, it's more that you are looking for the rate of change. At least from normal differentiation class, you should have learnt about that. And then you won't be jumping into partial differentiation if you don't know differentiation, like the normal differentiation, the one with differentiation ordinarily. So partial differentiation is just talking about you looking at the rate of a change of a variable, like with respect to one of the independent variables. So you have more than one independent variable, and you're differentiating the dependent variable based on one of them, leaving others constant. So like that's what it is basically trying to say. So we kind of need to know some things about indices, right? For example, when you have fractions, how to like make the whole thing easier for yourself to work with and all of that. So we'll be talking about some of those things today. So let's quickly go into a couple of examples. So we have examples. First, let's say you have y. The normal thing that you do, you probably have something like this: y equals 6x plus 3 under normal differentiation. And then when you're looking for the y, the x, so the x here has a power of 1, right? So I can rewrite this as 6x which power 1 plus 3. And when you're differentiating the 1 here, the 1 which is the power comes to the back of 6. So you have 6 x 1 minus 1. There is no x here at all, right? So it becomes a constant, then that's gone. So we are left with 6x raised to power 0. X raised to power 0 is 1. 6 times 1 is 6. Right? So it's as simple as that. But for partial differentiation, you may have something like this. Z equals 6xy. So now you have two independent variables. So the question can say look for the direct derivative. Look for the first order direct derivative. So what does that mean? It just says you find the zx or the zy, first order direct derivatives. So what if it asks you to find the second order direct derivative? So it's just telling that you are still differentiating with respect to the initial variable, but now you are doing it twice. So that's going to be zxx and zyy, right? Second order direct derivative. So you may also be asked to look for the cross partials. Cross by just like you have cross elasticity of demand, looking at the price of one changes in the price of one commodity and how that is influencing the demand for a different commodity, right? So here, if you're looking for cross partials, you are differentiating. You are going to be having something like this: z x y or z y x in this case. So you have zxy. So you differentiated with respect to x initially. So when you're now doing your second, instead of doing a second order derivative with respect to x, you're now differentiating zx with respect to the second variable, which is y. Right. So this is first order direct partial derivative, second order direct partial derivative, and then this is not that's not third order, that's just called cross partials, like for the derivative of one variable and all of that. So um, looking at 6xy here, if you are differentiating with respect to x, that is the meaning of zx, you are differentiating this with respect to x. Now, if you look at it, this can be written as 6x raised to power 1, then y. They are multiplicative, right? So what is this now going to be? No, this is not zx, this is just z. So zx in this case is going to be 1 6 x 1 minus 1. You still leave the y because it is multiplicative. You have the y with so the y is like a constant now. So it's the same way we had 6x in this case. We only differentiated x. We didn't take the 6, we didn't disappear. So the 6 was there, right? So when you differentiate with respect to x, you still leave the 6, which was the constant, because it is multiplicative. Now we couldn't do anything to 3 because that is additive. Like 3 is you're adding 3 to 6x, and 3 has no x beside it, right? But when 6 is multiplying the x, so like they are together like that, nothing can separate them, right? So you leave 6 as a constant of x and then you continue. So here too the same thing, you leave y as a constant of x here, and then you continue. So it's as if 6y is the coefficient of x, right? So like that's the way it works. So this is now going to become, of course, x y 1 raised to it becomes 0. So we have 6y left, and that's just it. So simple. Now then let's look for zy. So given this again, so in that case, okay, let me just write this one like, let me just call it something like this. So 6l1 y1 to make things easy. All right, so now the same thing, you differentiate with respect to y now. Now because it's multiplicative, every other thing is like the coefficient of y. So we now have 1 into bracket 6x, no, 1 into bracket 6, x still is still there, then y 1 minus 1. So this is 6x y 0, which is equal to 6x. So you can see easy, right? Easy. All right. Okay. So what if we then have what if we're now to look for the cross partials? So I want to show us something because the cross partials they are equal to each other. So whether you have zx5 or zyx, they should give you the same answer. So looking at zx equals 6y, right? So let's look for zxy. So you are differentiating 6y now with respect to y. Right. So and this is just going to give us this is 6 raised power 1 6 y 1 minus 1, and we are left with 6. All right, so let's look for zyx. So zy from what we did was 6x. So we are differentiating zyx. So you are differentiating z in respect to x. So this is still going to be 1 6 x 1 minus 1, and then this is going to give you 6. So if you look at it, zxy equals zyx. So in cross partials, your derivatives should be equal to each other. So we may call something zxy and then we may call it zyx. Like what you should get is the same thing. So like these are simple stuff. So now let's begin to look at more examples. I think I mentioned it earlier that there was no way you'll be watching a video on partial differentiation that you wouldn't have done the normal differentiation before. So we have a couple of exercises on the board. I'm going to solve everything, right? Just like make you understand this thing that we're trying to say more. So how do we solve this? So the question says we should find the first order partial derivatives of the following. First order partial derivatives of the following. So we are differentiating the dependent variable with respect to the number of independent variables that we have. All right, so solution. All right, so we'll be moving a little bit faster. The first one says A z equals, so from here zx is just going to be equal to 3. Right, since you only have x here, you don't have x in this other side, so it's just going to be equal to 3, and that solves that. Then B, I'm sorry, that's zx, then let me do it like this, comma, then zy equals, looking at this, there is no y here, so this disappears, is a constant, that disappears, there is y here, so when you do the z dy, you get 2, so that solves that. Then B, um, z is 17x squared, then y raised to power minus 3, so they are together. In that case, zx will be equal to the power on x is 2, so 2 multiplied by 17, x squared 2 minus 1. Then you leave y alone, so y is like a constant too, y is acting like a just like 17, so that's how you treat y. So zx here equals 34 x y raised to power minus 3. Then you can write this as zx equals 34x. From the law of indices, y raised to power minus 3 when it comes down becomes y raised to power 3. Right, so that's not difficult. Then let's try the zy. Zy is going to be the power on y is minus 3, so minus 3 multiplied by 17. You leave x alone the way it is, x squared, then y raised to power, be careful, minus 3 minus 1 is not minus 2, that's going to give us minus 4. So minus 3 times 17 is minus 51, x squared, y raised to power minus 4. So you can convert this into minus 51 x squared divided by y raised to power 4. So that's it. Then C, let's see what is in C. So C is kind of long. We have three. Okay, not three. We have two, just two independent variables, x and t. Okay, fine. So zx equals, we have x here, right? So it becomes 3 times 10. So this is 30 x squared. So we have 30 x squared. Then here plus minus 1 into bracket 12 x minus 1 minus 1. Then we don't have x in 8t, so it disappears. We don't have x in 24, it disappears. So what we have left here is 30 x squared plus times minus is minus, then 12x which power minus 2. So if you want to simplify it, then 30x squared minus 12 over x squared. So what I'm trying to say is, if you still want to simplify, you can leave your answer this way anyway. But if you still want to simplify it, you can have 30x squared minus 12 divided by x squared. So when x squared comes up, it becomes x raised power minus 2 from the law of indices. So if you have 1 over x, this is same as x raised to power minus 1, right? If you have 1 over 5x, it is 1 over 5 times x raised to power minus 1. That will give us x raised to power minus 1 divided by 5. So that's just indices. Now, I think we're done with zx, so let us do zt. So zt, you don't have t here, you don't have t here, you have t here, you don't have t here. So when you differentiate here, you just have 8. And that's all. That's all. Now for D, we have this is a utility function. So you normally, if you're studying economics, normally you are going to be dealing with utility function, something like this. Alright, so we have two independent variables. So here we are going to be having UA, differentiating U with respect to A. So if you're studying economics, you are going to be dealing with utility functions a lot. So as we were saying, UA equals 0.6 multiplied by 10. Now, be careful. This is A, 0.6 minus 1, 0.6 minus 1. Then, of course, B is just beside it. So, like, multiply by B, raised to power 0.5. Okay, so you can see the way this thing is working. So you have UA equals 0.6 times 10 is 6. 6A, 0.6 minus 1, that's minus 0.4. Minus 0.4, then B raised to power 0.5. So that's your answer. Now, what if it was UB that you wanted to do? All right. And what's the power on B? The power on B is 0.5. So you just do 0.5 multiplied by 10. You leave A alone. So because you're not touching it, A is equals 0.6. Then multiplied by B. The power on B is 0. It was 0.5. So minus 1. So UB equals 0.5 times 10 is 5. A 0.6, then B minus 0.5. So this can be rewritten, UB can be rewritten as 5A raised by 0.6 divided by B raised by 0.5. Okay, so that's about that. So what we have left now is E. So E, you know that is complex. There's nothing complex here. Okay, I think I can. Let's try to like make it a little bit complex. 5y cubed. So I've added a couple more exercises just for us to keep playing, right? You play with mathematics. So solution. I want you to understand these things really well. All right. So for E, Z. So let's just do okay. Let's try to like you have something like this. Okay, the issue here is with the denominator here. Like, what can you do? So the easiest thing to do, I would advise somebody to do, is first 16 divided by 5 can convert into a decimal. That should be 3.2. All right, so you have Z equals minus 4x cubed cube plus 8xy. So minus 16 divided by 5, 3.2. Then you have x squared. By the time y raised to power 3 is coming up, so y becomes y raised to power minus 3. All right. So because the way it is that the assumption is okay, you have this, you want to convert it, 16x squared divided by whatever. So 16x squared divided by 5y3. So the assumption is that there is also a y here raised to power 0. Of course, you know anything raised to power 0 is 1, right? Okay, maybe I should have written it here. So the assumption is you have 16x. I don't think this is very clear enough. So you have 16x squared divided by 5y cube. And I was saying that for you to bring this guy up, the assumption is that you have y raised to power 0 here as well, right? Y raised to power 0 is 1. So just for you to be able to work with the y3 that's underneath. And then this becomes 16 over 5, right? X squared is up, normally x squared. Then y raised to power 0, because of the division sign from indices, that's whenever you have division, so the power becomes a minus. And the 3 here, so it's going to be 0 here. The division sign becomes 0 minus then 3, the power of 3 before. And from here, 16 divided by 5 is 3.2. Then x squared, y raised to power minus 3. So it's as simple as that. So you can just like simplify the whole thing that way before you continue. So with that, we can now do our zx. So this is cube. All right. So 3 comes here. You have minus 12 x squared plus, when you differentiate here, you are left with 8y. Then this becomes minus 6.4x y raised to power minus 3. Leave it that way. Now when you have zy, so you remember you're not differentiating this because that's all you'll be getting is zxy. Right, so zy, come back to the original function. So zy, there is no y here, it goes away. There is y here, so when you differentiate, it's only y raised to power 1. So this becomes 8x, and there's y there, so you have minus 3 times. Okay, let me just, because some people don't like math per se, so minus 3, then 3.2 x squared y raised to power minus 3 minus 1. So we have 8x minus times minus is plus. 3 times 3.2 is 9.6, 9.6 x squared, then y raised to power minus 4. Okay, so that's it. I think this is easy enough to understand. You can collect like terms, you can take x out, and you can leave your answer this way, so it's fine. So when I say you could collect like terms, so you could have x into brackets 8 plus 9.6x y raised to power minus 4, or um, x into brackets 8 plus 9.6x. So it is only this one that is divided by y raised to power 4. So please don't divide the whole thing by y raised to power 4. So that being said, okay, let's go to the next one. X plus, where is it? X plus y raised to power 3. I don't know if this space can contain it. Um, so it's kind of simple. So zx is going to be equal to, this is just general power function rule. So 3 comes to this side, of course, like from your normal calculus, you've done it. But here you are differentiating respect to x, so you have no business with y. So we have 3 into brackets x plus y is still there, because that's how the function rule works. 3, then multiply by, when you differentiate x, what you have is 1. What's it? Okay, this is 2, like 3 minus 1, 3 minus 1. So zx equals to 3 um, x plus y square. So you don't make this y to become 0 because it has a power, like the whole thing is inside it. The whole thing is raised to by a particular power. So you don't just eliminate y like that, as is because you are differentiate respect to x and then you eliminate y. So it doesn't work that way. Uh, zy here is the same process. So it becomes 3x. Maybe I should have made this guy 2y. I think let me just make this one 2y to show you something. Okay, so let's make this guy 2y. So you have x plus 2y is also going to have squared. Then you multiply by, you differentiate what has y inside the bracket. So you don't come here, you have no business with it because y is not there. So when you differentiate what has y in the bracket, it is this 2y. So 2y will become 2. So zy equals 3 times 2 is 6. 6 into brackets x plus 2y squared. Okay, so that's it. So if you want to differentiate this particular one, you are going to be using the product rule, and this one is going to be the quotient rule. So let me solve the remaining two as well, and then know that I've kind of taught you through, I've walked you through the different things that you can do, and then we have an assignment. So for this next guy, um, remember that when you have a product, what you do is you the v the x plus v the u the x. Not as if I'm going to be adjoining to this thing strictly. I'll just like be fast because you know how to do this anyway. So zx is, if this is our u, this guy is our u. Color coding helps some people sometimes. This is u, and then this is v. And so we do u the v the x. So you leave this. So you have x squared y, x squared y, dv dx. This is v. So you differentiate this with respect to x, dv dx. So I will do that. We only have x here. All right, there's no x. So the whole thing there is just 12. 12. Then plus, what is v? V is 12x, 12x minus 8y. Then du dx. Yeah, so you differentiate this with respect to x. So you'll be left with 2xy. Okay. 2xy. So that's that. 12 multiplied by this, 12x squared y. Then we have to be careful here. 12x multiplied by 2xy. That's plus 24x squared y. Okay. And then plus times minus. No, what did I do? No, minus here times what is it? Okay, it is still minus. 8 times 2 is 16. So 16 x y squared. Is there any like them? So we have x squared y here, you have x squared y here. So we can have 36 x squared y minus 16 x y squared. So that's zx, right? Now for zy, the same thing. This is u v. So the formula for that is going to be u the v the y plus v the u the y. Okay, so zy equals, so what is u? So you still like leave it that way, x squared y, now into bracket dv dy. So if I share that with respect to only y, so we have minus 8. Okay, and plus, what is v? V is 12x minus 8y. Then du dy is just x squared because y disappears, and then that's x squared. So from here, minus times this, minus 8x squared y, then plus 12x times this, that's 12x cubed, then minus 8x squared y. Alright, so if you want to do second derivative, whatever, you go on and on like that. So that's simple. So that being said, we're now moving to the next one. Since the last one is a fraction, so the rule to solve that is quotient rule. So v the u the x minus u the v the x divided by v squared. All right. So this is u. I could actually solve this thing like not easy. I can solve this using the product rule too. So if I want to do that, it's just going to become x plus y, x minus y raised to power minus 1. So that's just it. I take the whole thing, I take it, I move the denominator up, so it carries a minus 1. So it is even easier to solve like this. But some of you are not that very great with math, so like let's just follow um, this person's method. So zx is equal to um, this is v. V is x minus y. So you have x minus y. Then du dx. So this is du, right? So you just, this is u. So du dx here is just 1. 1 differentiates u with respect to x, that's just 1. Then minus u is x plus y. Then dv dx. Dv dx here too is 1, right? Respect to x, that's just 1. And everything divided by just, I can just do like this, v squared, and v squared is x minus y squared. X minus y squared. So zx equals x minus y, then minus, this minus is going to multiply everything that is here, minus x minus y. So you have to be careful, not minus x plus y, because you have minus x, then minus y. Now everything here divided by x minus y squared. So x minus x, like this is going to cancel out. But minus y does not cancel out. So minus y is minus 2y. So you have minus 2y divided by x minus y squared. So you can solve this using the product rule to see if that's not what you are also going to get. Now for zy, the formula for that is going to be v. So you are differentiating u with respect to y now, v du dy minus u dv dy. All right, everything divided by, it's meant to be everything here, everything divided by v squared. So the same process, zy equals what is v again? X minus y. So x minus y. But now we're differentiating u with respect to y, so it is 1 as well. 1 minus, what is u? U is x plus y. When differentiate that with respect to then dv dy. Dv dy is minus 1. Minus 1. So everything divided by v squared, which is x minus y squared. So we have x minus y. This is minus, so minus times minus is plus. So we are left with plus x plus y. So everything divided by x minus y squared. Again, minus is there, so minus 1 times minus is plus 1. So plus 1 multiplied by x plus y is just x plus y back. Alright, so in this case, it is minus y that is taken away plus y. So x plus x, that's 2x, divided by x minus y squared. So which can also be written as 2x into brackets x minus y raised to power minus 2. So I don't know. Okay, I didn't even, did I simplify this one like that? I didn't. This is going to be minus 2y into brackets x minus y raised to power minus 2. So you can see it's more or less like the same thing, just that here you don't have a minus, here you have a minus. Denominator is the same thing. And then difference, when you differentiated with respect to y, you had x starting it. When differentiated with respect to x, you have y being your numerator. Okay, so that's not about partial differentiation. So with this, I think we've done a couple of examples, maybe 8 of them or something. So I think you should be able to like destroy any question that comes on partial differentiation. Let me just write a couple of assignments. Let's change some variables here. So we have a few assignments on the board, a handful, don't let me say few. So find the first and second order partial derivatives of the following. So you have this is A, and this is B, and this is C. So 3 of them. So first and second partial derivatives. First and second order direct partial derivative. So you are not looking for cross direct partial derivatives. Now for number 2, show that zxy equals zyx and the function below. So x minus y divided by y minus x. So you show that zxy is equal to zyx. Number 3, find the cross partials of the function below. So you have k, l, r. So you have 3 variables. So qkl, qkr, qlk, qlr, no, whatever like that. So I think you might be getting up to like, you should be getting up to like, maybe, is it 6? 3 factorials, that's 6, right? Yeah, so you should be getting maybe something around 6 different functions. So when you solve, you begin to see the ones that are equal to each other. So thank you very much for this class. As MOU's Club Economic students, you know where to submit your assignments to me. And then if you are a student watching this video and you want to contract us, you want us to teach you maybe any of your courses in school, so you can just check the description link of the video, find a way to reach out to us. You can buy our courses, you can enroll to be one of our students, right? We teach undergraduate economic students, and then you can look for us to teach you one-on-one tutorials. So thank you. Have fun. Bye.